family functions. So transforming linear functions. We're going to be working with family functions. And family functions, if you think about it, family functions are just like a regular family. Family functions are functions whose graphs share basic characteristics. They're the basic same shape. Now, are they exactly the same shape? No. Family functions are like a family. If you think about your family, unless you're adopted, or like me, I look like nobody in my family, so maybe that brings up something. Right? But you all kind of look alike. Does everybody look identical? I mean, minus Emma in here, who has an identical twin, right? You kind of have similarities, but you're not exactly the same as your family. But you share basic characteristics. We have the basic same shape. Maybe you have the same eyes as someone in your family, but you're much taller than everybody else. There's a family resemblance. So family functions are all basically the same shape. If they're all, they all have positive slopes, or they all have the same y-intercept. Right? So there's similarities. The parent function is the most basic function. The parent function always is going to be f of x equals x. That's the parent function. That's the very beginning. That's the very first thing. And remember, f of x really means y equals x, but this f of x is just function notation. It's the same thing as saying y equals x. And in this equation of y equals x, what's your slope? 1 over 1, right? And what's the y-intercept? 0. So if I was going to graph my parent function, I'm going to make it really little. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If I was going to graph my parent function, this is where every function begins. The parent function starts here at 0. Let's do it in a different color. And the slope is up 1 over 1, up 1 over 1, up 1 over 1. This is the beginning of every function. And then we add things to it. Maybe we change the y-intercept so it moves up and down. Or maybe we change the slope so it becomes less steep or more steep. But the parent function, the very beginning, is y equals x, or f of x equals x. A transformation, what does it mean if something transforms? Yeah. A transformation is a change from the original. O-R-I-G-I. It's hard to write and spell sometimes, folks. It's a change from the original. And there are three types of changes. The first type of transformation is a translation, which is a fancy word for slide. A translation is a slide. And all this is the y-intercept changes. A translation is the y-intercept is different. So let's make little graphs again. And if I'm doing f of x equals x, 1, 2, 3, I can just do 3 this time. Can you graph the parent function? If f of x equals x, that's the parent function. If I'm going to graph it, right, I start at 0 and I go up 1 over 1, up 1 over 1, up 1 over 1, down and back, down and back, down and back, right? Here's my parent function. And we're going to do a translation. So my next one I'm going to graph is f of x equals x plus 2. My y-intercept changed. Instead of it just being f of x equals x, now I'm doing f of x equals x plus 2. So what's going to happen to this red line? What do you think is going to happen to it? It's going to slide where? It's going to slide up 2. So again, let's make a really quick graph. 1, 2, 3, 1, 2, 3. And this time, my parent function started at 0. Where does this function start? At 2. Because my y-intercept is 2. And what happens to my slope? Is my slope the same? What's my slope for this line? 1 over 1. So up 1 over 1. It stayed the same. So if the y-intercept changes, all I do is slide my line up. Instead of it starting at 0, I just slide it up and it starts at 2. Where's this graph going to start? F of x equals x minus 3. What's going to happen to it? It's going to slide down how much? 3, because it's negative 3. Does that make sense about the translation? You're looking at it to see what happens. See how it's a visual thing? This is my parent function. And then it slides up 2. This one's going to slide down and start at negative 3. The next kind is a rotation. What does it mean for something to rotate? What's an easier word than rotation? Yeah, spin, or we call it a turn sometimes. So in a translation, the y-intercept changes. In a rotation, what do you think happens? There's not an x-intercept in y equals mx plus b. Right? Our y-intercept changes in a translation. What do you think about a rotation? What's the other thing that could change? The slope changes. A change in slope. Let's start again with our parent function, where everything begins of f of x equals x. 1, 2, 3, 1, 2, 3. And hopefully the parent function gets pretty easy to graph. It's just a perfectly diagonal line through the middle. And let's graph this next function that is 2x. Where does 2 comma x start? What's the intercept? 0. And what happens to my slope? What is my slope for this line? Up 2 over 1. And the opposite is down 2, backward 1. And look what happened to my line. When the slope changes, the line turns. It rotates. It went from here to here. Let's make another graph of 3/4 x. What happens when the slope changes? What happens when the slope changes? This starts at 0, right? I go up 3 and over 4, down 3 and backward 4. It rotates. A change in slope is a rotation. It affects its steepness. The bigger the number, the steeper the line. The smaller the number, the less steep. What can you tell me about a reflection? What do you think a reflection is called? The opposite, it's a flip. And a flip is opposite slope, meaning positive to negative or negative to positive. You make the slope negative if it's positive, and you make the slope positive if it's negative. So again, let's start with f of x, and let's do 1/2 x plus 1. Let's not start with our parent function. Let's make a little graph. 1, 2, 3, 1, 2, 3, 1, 2, 3. Where does this graph start? Positive 1. And what do you do to graph it? Up 1 over 2. Down 1, backward 2. What would I do to reflect that equation? What's going to change in my reflection? What do I do to reflect it? Cameron? Yeah. I change it to negative 1 over 2x plus 1. I change my slope. It was positive here, so I change it to negative. And let's see if that was right. Does Cameron write about flipping it? 1, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3. Let's see. Does that reflect? Meaning, does it flip over? Well, it still starts at 1. But this time I go down 1 and over 2. So up 1 and backward 2. Did this line flip over? Yeah. So that is a reflection. All right, can you tell me from this parent function describe the transformation? So from the parent function, and our answer, our change is going to be this. This is where we begin. This is what happens. This is where we begin, and this is what happens. What happens to that graph? From here to here, what do you change? What do you do? What's happening? This is where we start, so this is our parent function, and this is our final function. What happens? Corbin, what's one thing that happens?
It rotates.
It rotates, right? And it's a big number, so it rotates steeper. You could leave that part out, but it rotates steeper. What else happens to that line? Parker?
It starts lower.
It starts, or, I mean, that's a bad word, right? But that's how we start graphing it, right? The y-intercept is down 6. It starts lower. The y-intercept is down 6. So there are two ways to do this. Either you can get really good at identifying the differences just by visually looking at them, or you can graph the two pictures and tell me what happens with the two pictures. Deal? Okay, you have 11 problems for homework. Your graphs can look just like these. They don't have to be beautiful.